take a look how we can read a reaction coordinate diagram to give us some information. And we'll take a look at it through the lens of kinetic versus thermodynamic control. And so in this case, we're going to say that we have compound A, and it's in equilibrium with B and with C, right? So it has two different products. It can make two different components. It can make, which one will it make? And so if we take a look at the reaction coordinate diagram, maybe we have something like this. We have A over here, and then we have B down here, and then C down here, right? And so we can see that C is lower in energy, and so C is going to be favored thermodynamically. Right, because it's lower in delta G. And so you may be thinking, all right, we're going to get C as a product, but that isn't necessarily true because you have to think about how we get there. So maybe to get to C, you have to go over a very large activation energy, while to go to B, there's a much smaller activation energy, right? And so we can see here that B, with its smaller activation energy, is kinetically favored. And remember, since these are all in equilibrium, it's possible for A to first turn into B, B to turn back into A, and then A to turn into C. In general, lower temperatures and short reaction times favor the kinetic product, while higher temperatures and long reaction times favor the thermodynamic product. And so while this example is very cool, it's actually somewhat rare. In most cases, the kinetic and the thermodynamic product are the same. But we'll see some cool cases where they're not, and we can think about how we can manipulate the reaction to get what we want.